Hello and welcome, friends. Today we are going to discuss harmonic progression. I hope you have completed the exercise in both arithmetic progression and geometric progression. Now we are moving on to harmonic progression. So let's first understand what harmonic progression is all about. Harmonic progression, basically it is a series in which the reciprocal of all the terms are in arithmetic progression. So basically this is a sequence of terms in which the reciprocals of all the terms form an arithmetic progression. Let us take an example to understand this better. Suppose this is the series that has been given to you: 1 by 2, 1 by 5, 1 by 8, 1 by 11, 1 by 14. Now we need to understand whether this is a harmonic progression or not. What are we going to do here? We will have to first of all find out the reciprocals of each of these terms. So these are the reciprocals. 1 by 2 becomes 2, 1 by 5 becomes 5, 1 by 8 becomes 8, 1 by 11 becomes 11, and so on. And now 2, 5, 8, 11 and 14, the reciprocals of all the terms form an arithmetic progression, and that is why now we can conclude that the original sequence 1 by 2, 1 by 5, 1 by 8, 1 by 11 and 1 by 14 was basically a harmonic progression. So harmonic progression is a series in which the difference between reciprocals of any two consecutive terms is equal. So let us understand in the above example what we have done. First, we have converted the terms in the sequence into their reciprocals, and if you would notice, you would find out that the reciprocals, i.e. 2, 5, 8, 11 and 14, the difference between any two reciprocals, consecutive reciprocals, is the same. That is 5 minus 2 is equal to 3, 8 minus 5 is equal to 3, 11 minus 8 is equal to 3, 14 minus 11 is equal to 3. So this is another characteristic of an arithmetic, of a harmonic progression. Let us take some examples. 1, 1 by 11, 1 by 21, 1 by 31 and 1 by 41. Now if you'll find the reciprocal would be 1, 11, 21, 31 and 41, which is basically an arithmetic progression. The reciprocals 1, 11, 21, 31 and 41 now become an arithmetic progression because the common difference is 10, and that is why 1 by 11, the corresponding series 1 by 11, 1 by 21 is basically a harmonic progression. Likewise, if this particular sequence is given to us: minus 1 by 3, minus 1 by 7, minus 1 by 11 and minus 1 by 15, what are the reciprocals? The reciprocals would be minus 3, minus 7, minus 11 and minus 15, and you would find out that the common difference in this particular series is of minus 4, and the reciprocals actually form an arithmetic progression, and that is why this particular series is a harmonic progression. Again, minus 1 by 5, 1 by 7, 1 by 13 and 1 by 19. Let us find out the corresponding arithmetic, let us find out the reciprocals of these terms. The reciprocals would be minus 5, 1, 7, 13 and 19, which together form an arithmetic progression with common difference of 6, and that is why minus 1 by 5, 1 by 7, 1 by 13 and 1 by 19 will be a harmonic progression. So is this fine? So what do we do to find out the nth term of an harmonic progression? How do we find out the nth term of an harmonic progression? Let us understand. First thing that you have to do is you have to convert the harmonic progression into its corresponding arithmetic progression. How do you do this? by converting all the terms into their reciprocals. So this is the first step that you'll have to go for. Convert all the terms in the series to their reciprocals. Now these reciprocals would be forming an arithmetic progression. Now you have to find out the nth term of this arithmetic progression. You know that we already know how to find out the nth term of the arithmetic progression. You would remember this formula from our discussions earlier. So basically this is the formula that we'll have to use, and this way you will find out the nth term of the corresponding arithmetic progression. And in the last step, what you'll have to do is you will have to do the reciprocal. You will have to convert the nth term of this corresponding AP into its reciprocal, and that would be the nth term of the harmonic progression. Let us take an example to understand this better. Find out the 7th term in the series 1 by 3, 1 by 13, 1 by 23 and 1 by 33. Now first thing for us is to ascertain whether this is an HP or not. At least this is not an arithmetic progression for sure, that you can find out by subtracting the earlier number from the number that appears later. For example, 1 by 13 minus 1 by 3 or 1 by 23 minus 1 by 13, you will see that the differences are not equal, and that is why this is not an arithmetic progression. But if you convert this series, if you convert every single term in this series to its reciprocal, this would probably become a harmonic progression. So the first step will be to ascertain whether this is an harmonic progression or not. We convert all the terms into their reciprocals. So now once we have done this conversion, now we'll have the four terms 3, 13, 23 and 33. And since this is an AP, because 13 minus 3 is equal to 23 minus 13 and is equal to 33 minus 23 is equal to 10, the difference is same throughout. The reciprocals actually form an arithmetic progression. Hence we can say that the original series was harmonic progression. 1 by 3, 1 by 13, 1 by 23 and 1 by 33 basically was a harmonic progression. Now once you have ascertained this, what we have to do is we have to find the nth term of the corresponding AP. Corresponding AP means the series that we had obtained by converting every single term of the given series into its reciprocal. So the corresponding arithmetic progression here is 3, 13, 23 and 33. You know how to find the nth term. In this case the nth term is the 7th term. How to find the 7th term? We've already done this. Please do this calculation on your notebooks. So you know already how to find the 7th term. We'll find the 7th term and it comes out to be 63. Now this is the 7th term of the arithmetic progression 3, 13, 23, 33. However, we have to find out the 7th term of the harmonic progression. So how do we do that? The third step and the last step would be, when you have to find the nth term of the HP, you have to do the reciprocal of the nth term of the corresponding AP, which means if I have to find the 7th term of the HP, I'll have to convert the 7th term of the corresponding AP into its reciprocal. In step 2, we found out that the 7th term was 63. So naturally, the 7th term of the harmonic progression will be 1 by 63. Is this clear? So this is the methodology that you'll adopt while solving these kind of questions. Now let us take one more example. Now here we have to find out the 10th term. Deliberately I have taken negative values also. The first term is minus 1 by 2. Please notice this particular fact here. It is actually minus 1 by 2 and not 1 by 2. The second term is minus 1 by 5, then it is minus 1 by 8, minus 1 by 11 and minus 1 by 14, and we have to find out the 10th term. We know for sure that this is not an arithmetic progression. This is again not a geometric progression, but is it a harmonic progression? That we'll have to ascertain first. So we do the reciprocals. We convert all the terms into their reciprocals. We'll get minus 2, minus 5, minus 8, minus 11 and minus 14. Now you'll see that the difference in any two consecutive terms is the same. And since this is the case, and the difference is, you would notice that the difference is minus 3. minus 5 minus 2 is minus 3, minus 8 minus 5 is minus 3, minus 11 minus 8 is equal to minus 3, and so on. So the series that we have obtained by converting the terms in the original series into their reciprocals is this: minus 2 minus 5 minus 8 minus 11 minus 14, where the common difference is equal to minus 3, and this is basically an arithmetic progression. So the original series is also a harmonic progression. This we have now proved. Now we have to move over to the next thing. Now we can find out the nth term of the corresponding arithmetic progression. We have found out the corresponding arithmetic progression: minus 2 minus 5 minus 8 minus 11 minus 14. We know the formula: Tn is equal to a plus n minus 1d. We'll apply the formula, we'll put in the values. We know that the common difference is equal to minus 3, first term is equal to minus 2, and the 10th term, since we require, so n is equal to 10, and we'll find T10, and T10 will come out to be minus 29. Please do these calculations on your notebook on your own and then cross check your answer. Now the 10th term is minus 29, and now, but the question does not end here, because we don't have to find the nth term of the corresponding AP, we have to find the nth term of the harmonic progression. So how do we find the nth term? How do we find the 10th term of the harmonic progression? We have found out the 10th term of the arithmetic progression, that is minus 29. So the 10th term of the given harmonic progression will be the reciprocal of minus 29, and it will be minus 1 by 29. Is it okay? Now I hope you have understood the logic and also understood the methodology of solving such questions. Now let us test your understanding. These are the questions that you'll have to attempt. Kindly attempt these questions and then cross-check your answers with your batchmates. In case you have some query, you can come back to me. One last thing which I would want to talk about is that you would notice that we have not discussed the formula for adding up the first n terms of a harmonic progression, finding out the sum of first n terms of a harmonic progression. This formula we have not worked out. While we had worked out such formulae both for arithmetic progression and geometric progression. The reason why we have not done it, because no such formula actually exists. You simply cannot find out the sum of n terms of a harmonic progression using a formula. If the harmonic progression has only 5, 6 or maybe 8 or 10 terms, you can simply find out all the terms and add them up. But again, if the harmonic progression is 2000, 3000, at least manually you cannot do it, but you can use computers, and you can also make use of various softwares. But there does not exist any formula to calculate the sum of first n terms of a harmonic progression. So that's the good news for you. You don't have to remember one more formula now. So the job for you now is to go through this particular video lecture again, understand all the concepts that we have discussed, go through the examples again. You can pause the video wherever you feel like you are not able to understand, you are not able to follow, and kindly ensure that you are able to understand all the examples, and then please also attempt these questions. And very soon we'll be having a test. Hope you enjoyed this video lecture. This was a short one, you must have enjoyed. Have a great learning, and thank you very much.